Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So last week I started on a quest to try and reduce the amount of noise that comes off my radon mitigation system. It sounds like this, in case you missed it. Yeah, that's annoying, and that's the sound from our back patio. That's amplified, it's not that loud, but it is very annoying. So I came up with kind of a prototype that I had in mind for a while. This is sort of a cutaway of what is inside this. It is an open chamber that's hollow with some gyroid infill, and I was kind of hoping maybe the sound waves would come in here, bounce off in all different directions, and maybe the phase would kind of cancel out as we get different delays. It sort of worked a little bit, not very well. This was the full-scale model. You can see the gyroid infill inside of there, and what you can't see, of course, is the open space inside of here. It worked more like a resonator than anything else, which is kind of, I guess, what it looks like. Actually, a good friend of mine watched the video and said that it looks like a giant candy corn, and now I can't unsee that. It's just always going to look like a giant candy corn. I guess that's the downside of just trying to use up old filament for prototyping. But a bunch of you guys down in the comments gave me a tremendous amount of good information to think about. It's not just this video, it's so many videos on this channel where the feedback I've gotten and the comments that you guys have given me have either pointed me in the right direction or helped me consider other directions to look. And one of the more popular comments was replace the fan, especially if it is old. And I actually dug up this is the original work order for the Radon install. We didn't live here at the time, but I have a bunch of documents that the previous owners left me, and I sort of redacted their name and signature out of here. But this system was put in March 12th, 2004. It's funny, we're in March now. So it's almost exactly 21 years since this system was put in. And they show a fan model here too, RP265. So it'll be interesting to see if that's the same fan that's out there. I'm pretty sure it is. I highly doubt that fan has been replaced. We've lived here since, I think, around 2013. So the fan would have only been about 9 years old then. So yeah, I doubt it's ever been replaced. So I purchased a new fan. And since I'm doing this work myself, I purchased pretty much the best fan I could find, which is the larger unit from Fantech, but more importantly, it's variable speed. So this one can really be a small, low power fan, or it can be a super powerful fan. And apparently it's adjustable. So we're gonna dig into this and check that out too. But before we do anything, I was just thinking we should probably go get some baseline figures. In addition to the noise that this thing makes, or the one that's out there makes, I think there's also a reading down in the basement, like water, like dyed water in a tube that measures sort of the vacuum draw on the pipe. So let's go down and take a quick look at that, because I want to make sure that I get a record of that before we do any more modification. And the other thing you guys mentioned was replacing the pipe itself. Don't get me wrong, there's a whole bunch of other great ideas there too about better designs for something that will muffle the sound a lot better. But if we're going to change the pipe and the motor, I feel like it makes sense to do that before we do anything else. Especially since I guess there's a possibility that just these changes alone actually resolve the issue. So I think I've got a piece of solid 4-inch PVC pipe or cellular core 4-inch PVC pipe to replace the sewer pipe that they used when they installed this. That is just like a really thin PVC material, and I think might actually be leading to part of our resonation problems. Is that resonation even a word? Okay, good. Yes, resonation is actually a word. It's just one of those words, I don't know, do you ever say a word and it just doesn't sound like a real word? Yeah, this is what I'm talking about. So there, I guess I'm taking a video of it, so I don't need to make a note. That is where it is now. And I'm noticing there's a line here from, looks like a marker, and the level's actually lower than that line. I don't remember if I marked that there or if that was already marked. Could be that the fan has just degraded a bit, or it could be junk in the pipe too. But all right, we want to make sure that we get back to at least that level. All right, let's open up this fan, make sure this actually does work and that we appear to have gotten the right thing. Okay, so it looks like we got two nice soft boots. Ooh, these are really soft. I don't remember what's out there now. I think it has flexible boots on it now, the existing fan, but they're definitely not this soft. That is for sure. That might solve some of our problem right there. I think you guys did mention that in the comments as well. And here is our new fan, and this looks to be physically about the same size as the one that's out there. I have a single sheet that came with it. Warnings on that side, quick start guide on this side. Fits PVC size 4-inch. And looks like some basic wiring information, which presumably is in here. Okay, that's interesting. Kind of expected to see more. So this one is supposedly variable speed. I guess that must all occur somewhere inside the unit, because like there's just the terminal block out here, and this is probably a potentiometer. It's got like a little scale. Yeah, this is a speed controllable fan. Okay, so to adjust the fan speed, 0 is off, 1 is min, 10 is max operating. Okay, so it's got a suggested range of 3 to 10 on the potentiometer. But I'm not seeing what controls the speed. Like I kind of thought there'd be some sort of a circuit board or something in here. I was kind of curious how they were doing that. I guess that is all somewhere sealed in here. Oh, look at this. There's weights on the impeller blades and up here. I'm guessing they've balanced this. That's pretty sweet. That probably minimizes the noise level that this fan produces. The more balanced that it runs. Definitely spins very easily. Well, I guess let's test this before we actually go ripping the other one out. It'll be hot, neutral, and ground. Let me go steal like a computer power supply cord out of my box of 5 million of them, and we'll just cut the end off and wire that on. All right, I found an old cable and I have just cut the end off and stripped the wires back. So we'll just wire this in and test this. All right, let's plug it in. It's weird, oh, there it goes. It acted like it wanted to start for a second, paused, and then started to run. I'm not sure, again, I'm not sure how the speed control works in this. It's really smooth, I'll say that. Screwdriver's a little big for this. Oh yeah. All right, well, I kind of wish we had some more time to play with this, because I'm really curious how they're accomplishing that. I don't know if this is like a 3-phase motor and then we've got like a tiny VFD circuitry in here, or if this is a DC motor or what, but the speed control is really, really smooth. Like it's infinitely adjustable within that range, and you don't hear any like cogging or jerkiness. I don't know if they're just chopping the power up or what. All right, the other thing I want to look at is the pipe itself. I think I have a piece of 4-inch cellular core PVC up in the barn, so we can go up and get that. The only concern I have about replacing that pipe though is the size. The outside diameter of the pipe that's out there now versus the pipe I'd like to put in is different. Someone commented they thought it was the same. I was thinking it was the same too, but when I went to check it, the pipe that they ran for the existing system is 4-inch PVC sewer pipe. It's really, really thin wall pipe. And that might actually be part of the problem of, again, the system resonating the way that it does. The pipe that I want to put in is Schedule 40 pipe. It's either a cellular core or solid wall. I can't remember which I have up there. But it is, I think, 1/2 inch larger in outside diameter than the existing pipe, which I don't know, when they ran that through the roof, because it goes up into the soffit and then comes out of the roof. I don't know if they drilled those holes to be a perfect fit for that 4-inch sewer pipe, or if there's enough of a gap that we'll be able to squeeze larger pipe up there. So let's go up and get that pipe, and I guess at least make sure that it is the stuff I'm thinking it is. Oh, and while we're going up there, actually it's a good opportunity. I want to show you guys something else. So if you guys have been following my solar install up in the barn, I want to give you guys a quick update. The 200-watt solar panels that I borrowed from my friend Tom have not been enough to keep the system current. Even on days where we have almost full sun, it's about break even, but if we get any shade or if we don't get sun, I lose ground very quickly. So I have been taking this like hunk of lead is what it feels like, 100 amp hour battery back and forth from the house up here to the barn. And this has been filling the gap in power. You know, I charge it up down here in the garage. I take it up on the hand truck, I connect it to the low voltage solar input, which is also the car input. It will take a 12 volt input on that low volt solar input. And then this tops it up enough that I can, avoid dropping down into the range where that box will shut off. However, this thing is a pain. You see I have it on the hand truck. It's quite heavy. I don't know what it weighs, but it's very heavy. And a company reached out to me, Lithium, and offered to send a battery that supposedly has the exact same specs as this. Let me show it to you. All right, so this is it. Again, this company is Lithium, and 100 amp hour, 12.8 volts. And what doesn't come across, I know, in the video is this thing is, it's not light, but it's nowhere near as heavy as that other battery. Let me get the other one up here. Let me go grab a scale. Let's see if we can weigh them. Let's see here. 70.2 pounds. All right, and this one, 21.6. That is a huge difference. It actually has me wondering if this thing is real or if this is a scam. Now, I mean, this is lithium iron, so I would expect it to be lighter, but that is crazy. And again, this is 100 amp hour, same as this guy, and this one is not 100 amp hour anymore. Yeah, 12 volt, 100 amp hour. This is a nice battery. This is an AGM battery out of Japan. It's a good battery. It's incredibly heavy. I originally bought this for running the trolling motor on my little boat. But if I can lug this thing up and back until I get the real solar panels out on the roof and then use this on my boat, I guess, in the future, that'd be awesome. I mean, it doesn't weigh nothing, but it's no problem to pick this up at all. For comparison, Mrs. FPF can't even lift this battery. Can't lift it, period. And probably anyone can pick this one up and carry it around. So let's take this up to the barn as well, and we'll plug this in while we're up there. Okay, so the other end of this cable is plugged into the XT60 port on the EcoFlow. That is the low voltage solar input. There's actually two solar inputs on the EcoFlow box, which is really nice. There's a low voltage one and a high voltage one. The high voltage one is really designed for, I think, stringing a bunch of solar panels together. And that's probably what we'll be using on here once we get the solar panels up on the roof. The low voltage input will work for, I think, a single solar panel or maybe two in a string. But it'll also work all the way down to 12 volts so that you can use it as a car input as well. Or in my case, I've been using it with that huge, heavy 100 amp hour sealed lead acid battery. So I'm going to connect this one up the same way I've been doing with that other battery, and let's just see what happens. All right, I heard a click from the relay, which usually means, yep, it is charging. So 103 watts we are seeing coming in. That's the exact same amount that I see coming from the other battery as well. I think there might actually be a setting in the EcoFlow app that allows you to control how many amps it draws when it senses that the input is around the 12 volt mark, so that it knows it's either from a car or from a 12 volt battery. But I'm gonna leave this setting the same as I do with the other battery, and then we'll be able to use the EcoFlow app to see how many watt hours, then we can convert that to amp hours because we know the voltage of the battery to figure out how much juice we actually got out of this battery. So we'll take a look at that later today. All right, we're back down here in the shop. I brought the pipe with me, and this is 4-inch Schedule 40 coax. This is a cellular core PVC drain waste vent pipe. So this is going to be a standard, I think, 4.5-inch OD on this pipe. So what I'm going to do is I'm going to go quickly model an adapter to go from I think we'll go from the inside diameter of this pipe up to the inside diameter of the other pipe, and then have a taper between the ODs to give us the best chance of forcing this stuff up through that hole. So I'm going to go design that. We'll get that printing, and then let's go up on the roof and actually take a look at where that other pipe comes through and see if we have any wiggle room, see if we can figure out what's going on. All right, let's turn this off before we go up there so I don't have to contend with that noise and also all of the air blowing out of the pipe. All right, got you guys sitting on a tripod up here. Hopefully you don't fall off the roof. So there's silicone around the top of this boot. You know, we had this roof done a couple years ago. I bet you they reused this boot and just put silicone all around it. It still feels reasonably flexible. What if it actually comes off this metal part? That would be helpful because this is caulked to the roof as well. All right, it doesn't seem like this rubber boot part comes off of the metal, or at least not easily. It looks like we'd get enough stretch out of this for the larger pipe. But what I can't tell is how much wiggle room we have where the pipe actually passes through the roof itself. So I think we might actually just have to disconnect the pipe and try and pull this up through the roof to find out. All right, let's get this fan out of here. And I brought the sheet out with me. Is there a model number on this? Yeah, RP265. So I'm pretty sure this is the original fan unit. So that makes it 21 years old. Boy, that looks just absolutely disgusting in there. We're going to replace this bottom coupler anyway, but I might just grab the vacuum and see if there's anything loose in there that does come out. All right, that looks a little bit better. Everything loose is out now. So I'm going to set you guys back out of the way because what I'm going to try and do is see if I can push this pipe up at all. I think it is moving. It's tight. I guess we could try and come back down with it too. Yeah, I guess the only reason not to come down with it is if we run out of space before we get to the ground, but I could just cut the pipe. I think I'm actually going to try lubricating that, that slip fitting a little bit, just maybe with some grease, so that we hopefully don't damage it as we pull this pipe down through. Okay, well, good news is this is definitely shorter than 10 foot, so we have enough pipe of the right type. I don't know, from here that hole drilled through the roof decking sure looks like the same diameter as the pipe. I don't think we have wiggle room. All right, I think I can use this guy to get the actual diameter of that hole. Yeah, that is not 4.5 inches. So that means we either need to put the original pipe back in or I need to enlarge this hole, which is going to be really tricky. Let me see if I can get you guys a better view down here. All right, I flipped this back up. I think that gives us a better view. So like this is the decking here. That's just the decking that's been cut through. But over here, you can see that it looks like they go right through a truss as well, which they probably should not have done. But if it hasn't been a problem for 21 years, I don't think it's going to be a problem now. But yeah, I think I'm going to need a bigger hole saw and a way to center up on that hole. We could probably 3D print something to guide the hole saw, but I don't think this is happening this Friday. All right, I've been up here for another 10 minutes or so, just sitting thinking about it, and I don't want to rush this. We could just put the original pipe back in here, put the new fan on and call it a day. I mean, that would be the easiest low effort thing to do. I think you guys know I'm not going to do that, and there's no way we're going to squeeze that Schedule 40 pipe through this hole up here. So here's what I'm thinking. We'll take the original pipe, we'll cut a short section of it, we'll either feed it down through from up here or we'll push it back up through from the bottom, because remember, the pipe doesn't penetrate the roof perpendicular. The roof is pitched, so the pipe comes through at an angle. And we're going to need that along with, I think, a 3D printed piece. We can design something that fits into the end of the pipe, maybe with a bearing in the center. Because if you've ever used a hole saw before, you'll know once you get the hole started, The hole itself keeps the saw on track, keeps it centered. But until you get that hole started and you have maybe a little bit of depth to work with that keeps the saw sort of in the track of the cut, the pilot bit is what keeps the saw on center. Well, there's nothing here for a pilot bit because we already have a hole that is almost the right size. We only need to make this a 1/2 inch bigger in diameter. So I think we can use a piece of the pipe in combination with a 3D printed insert with a bearing to keep the pilot bit centered to get the hole started. Then we can get that out of the way, finish the hole. I'll have to figure out something similar to do for the soffit down there as well, because that was also cut as a tight fit on the original pipe. So clearly I've got some design work to do. However, we can still get that fan on this week, and I'll have to make something to close this off as well so I don't get rain down in here. I think it is actually supposed to rain tomorrow. I think we could just 3D print a cap that's just a tight fit up here, maybe with a lip that comes over. It's surprisingly nice up here on this roof. I kind of feel like I just want to go get an ice cold beer out of the fridge and just sit up here on the roof and not even do anything the rest of today. But yeah, let's go put that motor on. All right, let's clean up this pipe first. This is going to be a real loose fit on this because this is sewer pipe. Yeah, I didn't think about that. This is really loose on here. I could probably cinch that down, but it's going to distort this. Like there is a 1/2 inch total gap there, so 1/4 inch on each side. Yeah, I think I'm just gonna go, let's go make a sleeve for that. All right, while we're waiting for all that stuff to print, I went up and I grabbed our battery because the EcoFlow box is actually at 100%. The sun came out pretty bright today, so between this and the solar panels connected, it's full. So we're not gonna get any more juice out of this. Let's just measure the voltage and see where it's at. 13.3. They probably have that's going down a little bit, 13.29. There's probably a state of charge chart available for this, but I think we can actually get all the numbers that we need. So the EcoFlow box tracks how much energy comes in from each one of the sources. So let me check that first. Okay, so according to the EcoFlow box, we pulled 196 watt hours of energy out of this battery, which isn't very much. If we divide that by the rated capacity of the battery, yeah, so according to this, we only pulled like 15.3% of the energy out of this battery that should be in here with this fully charged. And I did fully charge this first. I was kind of hoping to pull more out, but the EcoFlow box is full, so we're not going to be able to discharge this anymore. But I think we can actually see from the battery's perspective how much energy we pulled out of it as well. When I first opened this up, honestly, I kind of snubbed my nose at this right here because it's a battery. I don't need my battery to be Bluetooth. I mean, come on. But then I thought about it, and if this is lithium iron, which this lead-time battery is, that means there's a BMS in here, something to manage the battery because there's multiple cells and it's got to keep those balanced. So I guess if you're going to put a BMS in there anyway, you may as well let me connect to it. So yeah, let me go through the trouble of downloading the app for this and let's see what the battery thinks. All right, the app was actually really easy to download and install. I do have one complaint. Lead time, if you're listening, why do I have to create an account to launch the app for it to pair with the battery? I never understand that when apps insist that you actually create an account, but I created the account. So I can see now that the battery says that we have an 86% state of charge, that's within, it's within 1.5%, I guess, of what we calculated. And if we click in here, we actually get some other information as well. Yeah, so it's saying we have a remaining capacity of 86 amp hours, 13.3 volts. And yeah, that makes sense, 0 watts, 0 amps, because we're not drawing anything from the battery. I don't know what else we can do here. Oh, it's got temperature too. Cycle times 0, I guess because we didn't fully drain the battery. Balance. Okay, so these don't give us any additional details. We just get a happy little guy there. I guess because they're green, maybe these turn red if there's a problem. What else can we do? Discharge switch. Oh, that's cool. I guess probably the same SSR or whatever that provides the protection on the BMS for over voltage and under voltage. We can actually manually control that here. That's pretty cool. Power off. If I power it off, how would I use it? Oh, okay. So if we power it off, it turns back on when we charge it, which makes sense. I don't want to power it off though. I don't have anything connected right now, so we don't get to see the power draw. Presumably, we see the watts and amps in real time when we're drawing power from this. Let me see if I can find something to connect to it. All right, I've got this portable winch that I made years ago. This should do it. That's pretty wild. It is. It updates within, I don't know, maybe about a second. Yeah, so it gives you, while you're drawing power, it actually gives you the estimated runtime at that current as well. So I could see how that'd be really useful. Like if I do take this out of my boat, if I have the motor connected and I have the motor set at a certain speed, I could open up the app and see at the current amount of power I'm pulling how long I would be able to go in hours or minutes at that current draw. So that's pretty cool. All right, well, thank you to Lead Time for sending this out for us to play with on the channel. And I will put a link down in the description if you guys want to check these out. All right, that plug up on the roof is PLA. That's just temporary. It's only going to last till next week. The piece down here, this is white TPU. This is Sane Smart TPU. Printed this on the Cheaty Plus 4. This is going to be permanent. So TPU should hold up out here just fine, especially since it's going to be pretty much encapsulated underneath this rubber, which I'm sure is rated for outdoor anyway. All right, that is a nice fit on the pipe. Now, I wonder if it makes sense to actually put this in here because we do have a lip in here. That way that it can't get forced down the pipe as we slide this on. That seal on the liquid tight fitting is shot. Fortunately, that just looks like a standard O-ring, and I have kits of O-rings, so I'm going to go find one that is this size. All right, and we're running. So I think now I just need to adjust the potentiometer on here to see a similar draw on that little gauge down in the basement. So right now this feels like it's on like way low, so I'm going to crank it up a little bit. It's going to be a matter of running back and forth and getting it close. All right, I think that's pretty close. We could probably turn it down a little bit more, but I have a feeling we're going to have to turn it back up a little bit when we actually put the rest of that pipe on. Well, guys, I think we got to wrap this one up here. I was hoping to get the pipe and the motor in, but the motor didn't come until yesterday, which just really didn't leave a lot of time this week to work on this. I just went through my stash of stuff. I do actually have a 4.5-inch hole saw, and it's in good shape. So these larger hole saws, the arbors on these are removable, as well as the pilot bit out of the arbor. So it gives us a bunch of different options to think about in designing how we center and hold this to enlarge those holes up on the roof and the one in the soffit as well. So I've definitely got some thinking to do for those designs that we still need to come up with. And this is what that O-ring looked like that was in that liquid tight fitting. It is in really bad shape. And I just realized the other O-rings in the rest of those fittings are probably also the same. So I might pull those apart and replace those other O-rings. These O-ring kits are really great. This one is Imperial. This one is metric. At first I wondered if they were actually the same size O-rings in both kits, but they are actually different, which is really nice because I don't know that I've ever actually properly measured an O-ring. But having both of these kits, I don't think I've ever encountered a scenario where I wasn't able to find one out of the kit that didn't fit. So I'll link to these down in the description of the video. I've shown these on the channel before. This is one of those things that's not that expensive. That's great to have. It's stupid just to get stuck in a project needing something like an O-ring and having to wait for it when these don't cost that much to have on hand. Guys, as always, thanks for hanging out in the shop with me for this week's video. And thank you so much, again, for all your comments, ideas, and suggestions down in the comment section of last week's video. It is awesome to see that level of engagement. And there's so many smart people that watch these videos. It's awesome. Thank you again. I still think we're going to be visiting some sort of design for a muffler. I'm still thinking about doing multi-material. You guys have given me some awesome suggestions. I'm thinking maybe like an S-shaped or U-shaped chamber that is a little bit wider than we looked at before. And I really still am attached to this idea of doing it in like a softer material and a harder material on the outside. And saw some alerts come through. I think there's some packages on the way from Bamboo Lab that might come next week. So stay tuned, guys. And if this is by chance your first time here on the channel, this is all we do. It's all functional prints and the design and engineering and all the kind of stuff that goes along with those projects. So if you like that, if you're into that, more of that functional and design and engineering side of 3D printing instead of just multicolored garbage, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. Guys, if you do, I'll see you next Friday.